Alright, back to 100 Days of Mel. It's day 54. Today I'm going to be implementing what I learned from chapters 1 and 2 into a practical and technical problem. So, first things first, find an existing problem, determine if it can be solved using ML, and then look for data sets and determine what model would be suiting for that solution. So, in my textbook, part 1 has from product to goal to ML planning, estimate what is possible, measuring success, estimate scope and challenges, and yeah, and each one has different sections underneath. But first things first, let's get a problem to start estimating what is possible and figuring out models and data. Okay, so I have a couple of videos listed down. Just go through them once again and see which one would be suiting. Alright, so I'm going to pick this one. The basic product idea is the fact that through a camera, you'd be able to track an individual's progress. Well, okay, let's just not even include a camera. Let's just say that the entire product goal is to kind of track the progress of a task over time. Suppose if an individual wants to, I don't know, yoga every day for an hour, the product should be able to track the progress of that individual's time doing yoga over time. So the idea mostly came from the GitHub tiles, where you would kind of, for every commit, you would get a green tile on GitHub, and you could kind of get a visual representation of how many contributions you made per year. And I don't know, it looks kind of pleasing sometimes. It's like visually representing your data, where here data represents your work ethic. So in a way, I kind of wanted to have the same idea, but for not just for code, but also for everyday tasks that you want like a habit you would want to build, something like working out or doing yoga or studying. But the problem here is to figure out how to track the retention of the individual. So you would have to kind of determine if the individual is actually studying or doing yoga or, working out. And so the question is, how do you determine if they did it for that certain amount of time? For GitHub, it's pretty simple. It's a digital confirmation. Once a commit comes into play and then you push it into the GitHub repository, it's able to digitally acknowledge that push. But with everyday life like studying or yoga or exercise, you can't really the only way you trust, you have to trust the user. But some people could just fake it. Like, what if they didn't go to the gym, but they don't want to lose their streak? So they just fake input that they went into the gym. So you need some sort of validation, maybe like a photo confirmation or a video confirmation or something like that. Mm. And what I was thinking was having a camera. Well, at least for studying, you could have a camera in front of you, and then we could convert it into a classification task. I think I have something stuck in my throat. Okay, I cleared up my throat. Went to go get some water. Okay, so yeah, one way is to have a camera, determine through either some sort of classification model that runs on a video to classify if the user is either concentrating on studying or or whatever the task is, or if they're doing something else. But then you get into an issue here because when reading chapters 1 and 2, it's the suggestions that they make is to pick the most simple model and to pick a data set that's already available. It might be possible to narrow the problem to just studying or just yoga or just exercise, but having a combination of all of these tasks is very difficult because then you'd have to kind of create or find a data set to classify not only studying, but you'd also have to classify all the other different tasks that a user might be doing. And this becomes an issue. So I think something that would be more simple would just be like some sort of photo confirmation, like a photo confirmation with themselves in like a situation where either at the gym or I don't know. Like, what if they work at a home? Then their photo confirmation would just be at home, but how would you confirm they worked out? Mm. So yeah, an ML problem concerns itself with learning a function from data. For one particle, there's usually many different ML formulations. And the suggestions that the book gives is to evaluate ML feasibility by efficiently building ML applications. It's important to consider one of the simplest models that we can start off with. Also, looking at ways we can leverage existing data. So I'm going to look for data set. Maybe we could just narrow down the problem to just studying and see if there's any data sets on classifying studying. I don't think that's correct. I'm looking for papers. Okay, so I don't even think it exists. So this is not just a regular product idea. This would be like a research topic. But the question here is to how do you identify if someone's um, doing the task at hand? For example, if they're working out, they should be working out, or if they're studying, they should be studying and not like Googling or playing on the phone. Or if they're doing yoga, the same thing. They shouldn't be in bed, but they should actually be doing yoga. And the only way that's actually coming to my mind is to identify what the task is. Like have the model trained to recognize what the task is. And it would kind of be like anomaly detection, where if the user is not performing that task, it would become an anomaly, and you can have a probabilistic value of of like if they're focusing on the task or not. Let me search up another keyword. study is a very bad keyword. Let's try concentration. Usually just study just goes into like an academic study and air quality, transport. Okay, I don't see anything. Okay, anyways, a simple model in my head would not include um, video because video is very hard to process and it takes time. Maybe an evolution of a simpler model could eventually lead to developing a video-based model. And when I think about that, we could maybe have the users take a photo of either the environment that they're in or like somehow take a photo with them in the picture doing and with the background being the task that they're doing. Like suppose if I'm studying, I'll take a picture of me with like, that's hard because some people study with textbooks, but I study with electronic devices, for example, my iPad and, computer. So you have to determine, multiple ways to classify and train to classify, um, train to identify if they're like studying. Ooh, that's hard. I mean, the most simple model would be like, to see if they're actually, to actually detect if the user's in the image, and then trying to figure out what the background is. Oh, so for example, if you're studying, maybe you're at a deck. Maybe that's the requirement. That'd be a pretty good requirement. And the second would be, of course, if the user's in within the image. Okay. Hmm. All right. All right. Okay. And then maybe at the start of this company, we could have, since it's not going to be, we're not going to have a lot, assuming that we don't have a lot of users, we could have manual labor go through and classify if, that image is accurate or not. That way we have an ability to create a supervised model by identifying the labels for the images that are coming through through a manual process. So that way we have a data set. Well, we don't really have that data set because that data set only is created as users come in. That's a good question. How do you train a model to determine the background? You could have object detection, but object detection models are pretty hard. They're pretty complicated models, like detecting like desks and all that. So let's see. Okay, there's two parts to this model. One is to figure out the users within the model, and that's a pretty simple task. I think it can be possible if, let's say, we have a couple of images of the user in like different angles or something. We can validate their image or photo again. So I think it's called like face recognition. And face recognition research has come a long way. there's different sensors apart from just like the, what is it, camera. Well, your iPhone has like all sorts of different sensors to detect um, the depth of your face to a point where it can securely log in to your phone and also use it to validate payment and stuff. So there's some different ways you can do that. Mm, mhm. So user recognition through face recognition, support vector machines. Oh, yeah, I can access this. I don't have permission. Let's just try this. So here they're using 10 images of each person. Okay, here the importance would be like face recognition versus detection. I think what I'm trying to do is face. Oh no, it's face recognition. Because face detection just means to identify that there's a human face in the image or video. Face recognition is to confirm the identity. That's right. Okay, so for this problem, I've identified the data sets, the ML approach. Well, we still don't have an idea of how to detect the background, but the ML approach would be kind of like using manual labor to classify the data first. And then we would have to train that model to detect face recognition would be kind of easy, right? There's all the existing data. And if we have a pre-trained model and we suppose we ask the user to take a couple of images of themselves or provide a couple of images of themselves, we can use that as training data to update the model to recognize their face. And I think we can do this with a very small amount of images as well, like, like one or two or three images. So it's possible. Let's see. Next step, we'd have to detect the situation that they're in. So if they're sitting and I take a picture at my desk or something. Oh, hold up. Hold up. I just got another idea. Okay, okay. All right, so this might be possible. I mean, I see some loopholes here, but another way we could do this is have each user first identify their environment. So let's say they are doing a task, right? They add a task to this GUI, and then for their task, one of the requirements that the product could ask is to take an image of wherever they're going to be performing the task. So, for example, we could use that to train the background. And we can do a two-time recognition model where we can recognize the background as well as recognize the individual in the picture through face recognition. And now we combine these two models and then use that as our base model. I feel like that's what is, even though it sounds complicated, is the simplest way we could um, approach this problem. So, so far we talked about an existing problem. Well, it's not really existing, but it's a new problem that, well, it's an existing problem where the problem itself is identifying and tracking progress over time. And we determined if we could solve it with ML, we could. And I think the most appropriate solution would be to solve it with ML because you can't really validate someone performing a task otherwise. Like, ev- I mean, if the way I study is similar to the way someone else studies. The way I study is using my iPad, and the way someone else studies might be using um, like pen and paper, or other ways of studying. Someone might study at the library. I might study at my desk. Someone might be studying in class. So there's always different ways to study, and I think the way we could solve it with ML, like what type of model and what type of data set, is by user um, input. Okay, so they would identify the environment that they would be working in. For example, for me, I would take a picture of my desk, my desk setup, and this is primarily what I study. And if suppose they work at the library or they work at college or their college library or alternate places where they study, they can take images of that location and put it into the database. So now we could use those images to recognize the backgrounds of images that the users provide on a day-to-day basis. So the whole objective is to track progress over time and validate that they actually perform this task. And this validation process could come from a day-to-day. So, for example, if the task, let's say I want to do 100 days of ML every single day. Every single day, regardless of what time, I would have to take an image of myself in front of my desk. And that would be the validation process of me doing 100 days of ML. Even though 100 days of ML is very specific to, it could be classified as studying. And under studying, I can provide like image of my desk, and this is where I would work. So this seems feasible, and the data set would come from the users, but it would also have to be pre-trained. So the pre-trained part would be for the face recognition, we could train it on multiple faces and recognize faces and determine which user it is. That's very possible. There's a lot of data on face recognition that we could do. There's also a lot of state-of-the-art models. And apart from state-of-the-art models, there's also very simple models with OpenCV that we could use. So yeah, start simple. That's the basic goal, right? So first, we could start with their face and how to recognize like pattern matching using. How do you recognize an environment, like gym or something? One way is through object detection. You could say, okay, this picture has like two monitors and a desk, so it's kind of like their working environment. Or a gym would have equipment So that way you would classify based on object detection. But that's a hard task. Object detection is usually um, very hard to perform. So what would be an alternative way? I feel like initially, when the user takes an image of their desk and performs the like first 10 days of their um, task, it would have to be manually inputted by some sort of user. So we would have some sort of supervised, weekly supervised model, and we would use that to train to identify if it's their desk or not. So, for example, um, I do this task where I'm doing I'm going to be studying every day for 100 days, and I want to track my progress over time. And I provide a picture of my image. I mean, my desk where I would be studying. So every single day I wake up, I take a picture of me at my desk to validate that that day I studied. So over time, we build up a supervised data set, a labeled data set. That's what I'm trying to say, where the company user or company members would validate for the first 10 days if the user manually validate if the user was at the desk by referencing the base image they provided. So now we're labeling the data for the first, X amount of days. How many other days that we need to make our classification model? And then we could use that as our data source for the classification problem. And I'm not sure if 10 images or something like that would be enough because we'd have to pick some sort of pre-existing, pre-trained model to start off with. Let's see. Like veg, markup, nothing. Okay, when I was looking at computer vision and image recognition, I think there was ways to do it with OpenCV where the user provides like a bunch of images and then we could extract the based on user input. Any image recognition on load data. This is classification. What recognition? There's a slight difference. This is using state-of-the-art models. Maybe searching scholarly articles is not a good idea. Let me just do image recognition, then go into like articles. Yeah, but I guess for the base, we could have some sort of CNN model where it would predict based on the pixels provided. But yeah, the problem with that is that we don't have enough images at first. And I also talked about the solution to that. So some sort of simple CNN model where we wouldn't overfit the model would be a pretty good idea to start off with. And let's suppose that over time this supervised model builds enough data to, recognize their desk or something. We could then evolve the model to not just encapsulate images, but also video recognition uh, of like the tasks they're doing and or something like that. So over time, we're not only building um, a data set, but we're also keeping in mind that our data set can lead to a more improved model. So I guess that pretty much encapsulates everything that I've learned from chapter 1 and chapter 2, where for chapter 1 we talked about going from, well, formalizing the product goal into an um, ML approach. And chapter 2 is creating a plan, talking about the success of the model, the performance of the model, where I talked about it in a theoretical aspects, and we just estimated based on my prior experience. However, another way to do this would be to actually perform prototypes of the solution using Jupyter Notebook and some sort of small data set at hand. But yeah, I guess we kind of just verbally went through chapters 1 and 2 and talked about this problem. That's pretty solid. I think I'm going to end it for today. I'm going to kind of come back tomorrow with, um, what was it? Building a working pipeline. So tomorrow's more going to be implementation. Well, first I got to read the chapters, and then I could probably implement them. Okay, so chapter 3, which is build your first end-to-end pipeline, and chapter 4, which is acquire an initial data set. So that's pretty much it for day 54.